Greetings, my brothers and sisters. We are grouping and we are going to teach you about piecewise function. Now, for a question all of you about this topic, piecewise functions are functions that are broken down into smaller pieces or parts of functions. Certain conditions are required for us to determine which functions are to use for the problem first. For example, Dr. May starts for making coffees at 6 o'clock a.m. in the morning and drives for 10 kilometers in 15 minutes. He stopped at the restaurant to take some breakfast for 30 minutes, and from the restaurant he drove for 20 kilometers in 20 minutes before finally reaching the mini office. How far had he already traveled in 55 minutes?
So the horizontal line or the x-axis of this graph will be for the time taken, while the vertical line or the y-axis will be for the distance traveled. So for our first piecewise function, we will be using our first set of coordinates, which are, the first coordinate is 0, 0, which is the starting point, or the initial time, and the initial distance, since this is where Doc Mayo started. Since he traveled for 10 kilometers in 15 minutes, we will add the distance he traveled, as well as how long it took. So since he moved from the origin, we will be, since he moved from the origin, we will have 15, 10. So 15 minutes, and then 10 kilometers. So this is our second point. So that is 15 and then 10. For our piecewise function, we shall be using the slope-intercept formula. So this is y is equal to mx plus v. And we shall also be making use of the slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1 to get our n. So I'm sure these are very familiar formulas for everyone, since this was already tackled in our previous lessons in the previous papers. So for our first function, we have the coordinates 0, 0 and 15, 0. So our function will look like this. F is 1 times x is equal to mx, where x is the time or the duration of the travel. Now for each piecewise function, we must get the slope. So as well as the intercept. For m, if we're going to substitute or balance it in this formula, this will give us m is equal to y sub 2 is 10 minus y sub 1 is 0 over x sub 2 is 15 and x sub 1 is 0. So we can conclude this is 10 over 15 or simply 2/3. This is the m for our first function. So for a piecewise function, we already have, this will give us f sub 1 of f sub 1 of x is equal to 2/3 x plus b. So now, we already defined m. So now we already have m, but we should also find our intercept or the b. So to do that, we should simply substitute our values, either of the two coordinates, here in this equation to get formula. So if we're going to substitute, this is y, so let's use 10. 10 is equal to 2/3 times 15. Plus 50. So this will give us 10 times 30 over 3 plus b. This is equal to 10. This is equal to 10 plus b. And if we're going to transpose, then here is going to give us 10 minus 10 is equal to b. Or this is equal to b is equal to. So if we're going to put the value of b here, It's going to be 0, so we're just going to disregard. So this is our first piecewise function. F sub 1 of x is equal to 2/3 times x. Gets? Yes. So given our solution a while ago, our first function is equal to f sub 1 of x is equal to 2/3 x. If 0 is x is greater than 0 for n but less than or equal to 15 minutes. Since x is the time limit. So again, our first function is f of x is equal to 2/3 x if x is greater than 0 but less than or equal to 15 minutes. Just that simple. So for our next piecewise function, we must get the second set of coordinates. So the first coordinate we have 15, 15, 10 is our first set of coordinates for the second piecewise function. So this is 15, 10. So now we're going to get the second set of coordinates for our second piecewise function. So it says that he stops at a restaurant and eats breakfast for 30 minutes. So for our coordinates in our graph, we need the distance and time, right? But it says here, he stopped at the restaurant. This means that our distance, or y, will not change because he stopped. But our time is still going. So this means that our distance, or y, will remain the same. Whereas our time taken will be increased by 30 minutes since he took breakfast for 30 minutes. So it's around. So 15 plus 30, 15 plus 30 minutes of taking breakfast will give us 45. So our point right now is here in 45. But still in the quadrant of 10 in y, I mean still in the 10 value in y-axis because he did not move. Did not change his distance or his position. Therefore, our second coordinate will be, second set will be 15 and 10. 15 and 10 and 45 and 10. So why 45 and 10? Because 45 because he took breakfast for 30 minutes. But still 10, you can see it's still 10 because he did not change his position. So he stayed at the restaurant and ate breakfast for 30 minutes. So now I have our coordinates. Let us solve for our piecewise function. But for this function, we will be doing it differently. Since there is no distance, or there is no change in distance, y will still be 10. So for our second function, we will have f sub 2 times x is equal to 10. If x is greater than 15 and less than or equal to 45 minutes. So if you'll notice that we didn't solve anything simply because this is y. F sub 2 of x is the y, and like what we said, y did not change its value. So regardless any value between these 2 points, their y is equal to 10. So that's what we said here. F sub 2 of x is equal to 10 if x is greater than 15 but less than or equal to 45 minutes. So during this duration, their y is just the same. So that's our second piecewise function. Now for our third piecewise function, we have our first set of coordinates 45 and 10, since this is the last coordinate we have. And then for our second coordinate, we have to add values to our x and y. According to our problem, it says that from the restaurant, he drove for 18 kilometers in 20 minutes before finally reaching its destination or the clinic office. So that will become 45 for x value, 45 plus 20 since lasted for he added 20 minutes. So for the second set of values, we have to add values to our x and y. So it says in our problem that from the restaurant, he drove for 18 kilometers and 20 minutes. So since he drove 18 kilometers and 20 minutes, you will be adding 20 minutes in our x value and 18 kilometers in our y value. So this will give us 65, and then here is 20. So after driving for 18 kilometers in 20 minutes, in our graph, he is now here at this point. So he drove for 18 minutes, then 18 miles, and then 20 minutes. So this will become 65 and 20, our second set of coordinates. Now, just like we did in the first function, we need to substitute our values in the slope-intercept formula. But then, we must first get our m, or our slope, which is what we're going to do later. So this will give us 28, y sub 2 is 28 minus y sub 1 over 65 minus 45. So we're getting first our m since here in our slope-intercept formula, which is where we will be getting our precise function. We need the slope. So the slope is m, and m is equal to this. So this is what we're solving right now. So it's give us 18 over 20. Or if we're going to simplify 9 over so this is our slope, or m. Our slope is 9 over 10, but we also need to look for b, or the intercept. So for us to solve for b, we must simply substitute all of our values in our equation and then solve for b. So we're going to use this coordinate for the y. So y is equal to m is equal to 9 over 10, x is 65, plus b. So if we're going to solve for that, then a is equal to 585 over 10 plus b. Then a is equal to 58.5. So 585 divided by 10 is 558.5 plus b. And then let's transpose 28 minus 58.5 is equal to b. Then let's find subtract these two values. b is equal to 30.5. Negative 30.5. So this is our intercept, or b, here in this formula, and then our slope is 9 over 10. So now we've completed all of our values. So now we have the value for n and the value for b. We also have the value for y and x. We can now solve for our third function. So our function, given our values, so f sub b of x is equal to slope is 9 over 10 x plus or minus rather minus 30.5. So these are the values that we solve for variable. This is n, this is b, and then this is our function. So f sub 3 of x is equal to 9 over 10x minus 30.5 if x is less than 45, greater than 45 rather, greater than 45 and less than or equal to 65 minutes. So here we're going to connect with our graph. F sub 3 of x is equal to 9 over 10x minus 30.5 here in these values. So whatever value in this line segment, this is our function to use because x, this is the function to be used if x is greater than 45 but less than or equal to 65 minutes. So they have corresponding distances which will vary based on value if we're going to substitute for x. So now that we have our piecewise functions, let us now solve the problem. So first, let us refresh, let us list our functions. F sub 1 of x is equal to f sub 1 of x is equal to 2/3x. If 0 then f sub 3 of x is equal to 10 if greater than then f sub 3 of x 9 over 10 minus 30.5 x is greater than 45 and less than or equal to 65. So here are our three functions which we solved based on our problem. Now let's solve for the problem itself. So the question is, how far have we already traveled in 55 minutes? So nasa na siya after 55 minutes, nasa na siya dito after 55 minutes. So let us first determine which piecewise function we are using. Since 55 minutes is greater than 15, we're not going to use this. And since 55 minutes is also greater than 45, we're also not going to use it. So we are going to disregard these two functions, which leads us to our third function, which is already also suitable for our conditions because x is greater than 45, which is 55. 55 is greater than 45, but less than 65. So, masok siya dun sa ating third function. So, ito na yung ating gagawin, yung third function. So now we know what we have already determined what piecewise function we are to use. Let us now solve for our x or for our y. So x is equal to 55 is equal to 9 over 10 times 55 minus 30.5. So, solve. 55 times 9, 495. And then minus 30.5. And then 49 minus 30. So 49.5 minus 30.5, this will give us 90. So in 55 minutes, he has already traveled 90 kilometers. So we therefore conclude that in 55 minutes, he has already traveled 90 kilometers.
I hope you learned a lot from today's video. Thank you, my brother and sister. Till next time.